For the learning task number 2, I am going to solve an item from problem set number 3, which states that to measure the nickel content in steel, the alloy is dissolved in 12 molar hydrochloric acid and neutralized in the presence of citrate ion, which maintains iron in solution. The slightly basic solution is warm, and dimethylglyoxime, or DMG for short, is added to precipitate the red DMG nickel complex quantitatively. The product is filtered, washed with cold water, and dried at 110 degrees Celsius. The illustration below shows the balance equation of the reaction. It shows that 1 mole of the nickel ion reacts with 2 moles of the DMG to produce 1 mole of the DMG nickel complex and 2 hydrogen ions. The first part of the problem asks, if the nickel content is known to be near 3% by weight and you wish to analyze 1 gram of steel, what volume of 1% by weight alcoholic DMG solution should be used to give a 50% excess of DMG for the analysis? Assume that the density of the alcohol solution is 0.79 grams per milliliter. Before solving the problem, we first need to create a diagram. The diagram shows the process that was described earlier. From our given, we have 1 gram of steel that is 3% by weight nickel, which is dissolved in 12 molar hydrochloric acid, which is then neutralized with citrate ion. Then the solution is warmed and added with the dimethylglyoxime, which is the DMG, to precipitate the DMG nickel complex, which is obtained when the solution was filtered, washed with water, and dried at 110 degrees Celsius. Now that we know how to obtain the precipitate, we can solve for the required. It was mentioned in the problem that the nickel is 3% by weight of the steel, so we can get the mass of the nickel by getting 3% of the 1 gram sample, which is 0.03 grams. From the mass of the nickel, we can solve for the amount of DMG using gravimetric analysis. So we divide the mass of the nickel, 0.03 grams, by its molar mass, 58.69 gram per mole. And then we multiply it by their stoichiometric ratio. As we have seen a while ago, 2 moles of DMG reacts with 1 mole of nickel to produce the precipitate. Solving this gives us 1.022 times 10 raised to the negative 3 moles of the DMG in the solution. However, it was stated in the problem that 50% excess DMG is needed, so we multiply the obtained amount by 1.5. We now have an amount of DMG of 1.533 times 10 raised to negative 3 mole. Using the acquired amount of the DMG, we can solve for its mass. We multiply it by its molar mass of 116.12 grams per mole. So the mass of the DMG in the solution is 0.178 grams. It was mentioned in the problem as well that the solution is 1% by weight DMG, which means that per 100 gram solution, there is 1 gram of DMG. We can use this as a conversion factor in solving for the volume of the solution needed. So first, we multiply the mass of the DMG, 0.178 grams, by the conversion factor to solve for the mass of the solution. And then we divide it by its density of 0.79 grams per milliliter to solve for its volume. Computing so gives us a volume of a solution of 23 milliliters. The second part of the problem asks if 1.1634 grams of steel gives 0.1795 grams of precipitate, what is the percentage of nickel in the steel? Just like in the first part, we have the same diagram but with different givens. So in this diagram, we only have the mass of the steel, 1.1634 grams, without its percent by weight nickel, which is the required. However, now we have the mass of the precipitate, which is the 0.1795 grams of DMG nickel complex. So we can solve for the percent by weight of the nickel through gravimetric analysis. We can do this by first multiplying the mass of the precipitate by its gravimetric factor. So we have the 0.795 grams of the precipitate and multiply it by the molar mass of the nickel, 58.69 grams per mole, over its own molar mass, which is 288.91 grams per mole. And then we multiply it by its stoichiometric ratio. Once again, we have seen a while ago that for us to produce 1 mole of the DNG nickel complex, we only need 1 mole of the nickel. Solving the numerator gives us the mass of the nickel in the sample, and to get its percent by weight, we divide it by the total mass of the sample of 1.1634 grams and then multiplying it by 100%. Solving it gives us 3.134% nickel in the steel sample. Thank you.